Hi class, welcome to 7.4, identifying volumes of composite solids. A composite solid is just a solid made of many different shapes. And I have to warn you, the squirrels are torturing my dog who is barking and wanting to get out. So we may have to just listen to him. Hopefully he'll settle down. Anyway, we are shortening our assignment. We're working page 17 through 20, number 1 through 5. And I'm going to help you get started, but let you finish the problems on your own. So let's take a look at this. The directions for this lesson say for this practice, you may use a calculator, use 3.14 as an approximation for pi. Round your answer to the nearest tenth if necessary. 1. Find the volume of each of the following composite solids. A cylinder that sits on top of a triangular prism. All right, so this composite solid is made of two things. It is made of a triangular prism and it is made of a cylinder. And I have written for you the formulas for volume of a cylinder and volume of a triangular prism. You may want to pause it and write this down now. Okay, so let's see what we need. We have, for the volume of a cylinder is pi times the radius squared times the height. The radius is half the diameter, and we see right here that the cylinder has a diameter of 7 inches. So the radius would be half of that, and half of 7 is 3.5. So I'm just going to write that right here. The radius is 3.5. And the height of the cylinder, well, we can see that the height is 14 inches. So the volume of the cylinder, I'm going to just write volume cylinder, is pi, it said to use 3.14, times the radius squared, the radius is 3.5, squared, times the height is 14. So that's the volume of the cylinder. Now we need to find the volume of, you're going to use your calculator and do that, volume of the prism. And let's see what we have. Okay, this has a triangular base. I see that this is the symbol that means this is a right triangle in the bottom, which means that we can use the Pythagorean Theorem to figure out what this is. Because the formula for the area of the triangular base is 1/2 the base times height. Well, we know that the base is 20, this is the height, but we don't know what it is. But we know that this is 25. So we're going to use the Pythagorean Theorem to figure out what this height is, the little height. And so what you're going to do is put, this is a leg, the other leg is unknown, and this is the hypotenuse. So 20 squared leg plus, this is the height, the little h that we're trying to find, squared equals 25 squared. So you're going to subtract 20 squared from both sides. That cancels out. So we have height squared equals 25 squared minus 20 squared. And we don't want to know what the height squared is, so we're going to square root it. And put that in your calculator, figure out what the little height is. Now the big height is the height of the prism. That is from the bottom to the top. Well, over here it tells us that the height is 14. So the big height is 14. So you need to find the little height and the big height, and then you're going to put it in here. So it's going to be 1/2 times the base we said is 20 times the little height times the big height is 14. So once you find the volume of the cylinder and the volume of the prism, you're going to add them together. All right, B says a cone that sits on top of the cylinder. Here's the formula for volume of a cone. Pi r squared times 1/3 the height. The volume of the cylinder is pi r squared times the height. So let's look and see what we have. For the volume of the cone is up here. This is the diameter. So the diameter up here would be the same, which would be 2 feet. But I don't want the diameter, I want the radius. So if the diameter is 2 feet, the radius would be 1 foot. Okay. So if I have this and I have the slant height, I can figure out what this one is, and that will tell me the height of the cone. So I have the radius. I know the radius is 1. I need to figure out the height of the cone, but I know this is 1 and this is 4. So we can use the Pythagorean theorem to figure out this h. So I'm going to get it started for you. Height of the cone is going to be, this is a leg, h squared plus 1 squared equals 4 squared. Okay, so what I want you to do is put that, figure out what the height of the cone is. Once you know that, then you can put that into the volume of the cone, which is pi 3.14 times the radius. We said radius was 1 squared times 1/3 times, and you got to figure out what that little height is. So that's the volume of the cone. Let's look at the volume of the cylinder. It's pi times the radius squared times the height. Do we know the radius of the cylinder? Well, it matches the cone, so the radius is 1. Do we know the height of the cylinder? Well, yeah, we know the height is 5. So then we are going to find the volume of the cylinder, which is pi 3.14 times the radius squared, 1 squared, times the height is 5. So put that in and you'll figure out the volume of the cylinder. And then to figure out the volume of the whole thing, you would have to add them together. All right, let's look at 3. 3 says a cylinder has a hemispherical hole cut from the top of it. The shaded rim is 3 inches thick. Find the volume of the solid. Because this shaded rim is 3 inches thick all the way around, we know that the hemisphere is centered in the cylinder. All right, let's look at our formulas we're using. The volume of a cylinder is pi times the radius squared times the height. The volume of a hemisphere is, well, the volume of a sphere is 4/3 pi r cubed, but this is a hemisphere. A hemisphere is half. So half of 4/3 pi r cubed is 2/3 pi r cubed. So the volume of the hemisphere is that. All right, let's see if we have what we need. Let's look at the cylinder first. This is the cylinder. Pi, we know that that's 3.14, the radius. The radius would be from here to here, okay? I'm looking, I know that this part is 3 inches. I don't know what that is. All right, so I don't know the radius, but I do know the height is 12. All right, let's look at the hemisphere. The hemisphere, that's this part. Do we know, well, pi, the radius? Well, no, we don't know the radius. But if you'll look at this, here's the radius, here's another radius, and then this we know is 10 inches. Now the nice thing is this and this is the same thing, okay? So if this is x, then this is x, all right? So we're gonna put this into the Pythagorean theorem, which would be x squared plus x squared equals 10 squared, okay? x squared plus x squared is 2x squared. And let's go ahead, we know what 10 squared is, it's 100. I need to divide both sides by 2. So that means x squared equals 50. I don't want to know what x squared is, I want to know what x is. So we're going to square root both. So x equals, what did I do with my calculator? There it is. You need to figure out what the square root of 50 is. So square root 50 equals 7.071, etc. We're rounding to the nearest tenth, so the 0 is going to become a 1. So x is 7.1. Okay, so this is 7.1. This is 7.1. So the radius of the hemisphere is 7.1. Now the radius of the cylinder is going to be, the centers are centered. It's going to be 7.1 plus the 3 additional inches. So that is going to be, the radius of the cylinder is 10.1. Okay. So in this case, we have the cylinder and the hemispheres cut out. So instead of adding them together, we're going to subtract them. So the volume of the hemisphere is, well, we got to figure out the cylinder. This volume of the cylinder is 3.14 times the radius squared. Well, we said the radius is 10.1 squared times the height is 12. The volume of the hemisphere, is 2/3 times pi, 3.14, times the radius cubed. Well, this radius is 7.1 cubed. Is that it? That's it. All right, so you're going to get an answer, and then subtract them to figure out what's left. Got it? All right, number 3. The diagram shows a composite solid made of a hemisphere on top of a cone. All right, so here's our cone, here's our hemisphere. A says find the height of the cone, B says find the total volume of the solid. Here is what you need. Volume of a cone is pi r squared times 1/3 the height. That's for this part. See if we know anything. Well, we know the diameter is 20. So the radius, I'm going to put is equal to 10. I need to know the height. The height goes from here down, and I don't know what that is. This is the slant height, and that slant height is not the same thing as the height of the cone. All right, the hemisphere, we know the radius is also 10. And that's all we need to know for that. All right, so A says find the height of the cone. Well, I know this is 10. I know I'm making a right triangle here. This is my X. I don't know what that is, but I do know that this is 26. So the height of the cone, you're going to put this in the Pythagorean theorem. All right, the total volume of the solid, once you have this, then you have the height of the cone, and you can put those numbers in the formulas, and then add them together, and you'll get the volume of the solid. All right, number 4. Joanne made a jewelry box in the shape of a rectangular prism with the shape of a square pyramid. Okay, so the box, I guess this is the box and then the lid. So it's a jewelry box. Find the length of the diagonal of the base of the jewelry box, find the height of the cover, find the total volume of the jewelry box. All right, the volume, we've got a rectangular prism on the bottom and a square pyramid on top. I've written down our formulas. Volume of the rectangular prism, length times width times height. Do we know, okay, we know this is the length. Do we know the width? Well, if it's a square, then we've got this, these are the same. So this is 12. And do we know the height? The height is 8. So length is 12, width is 12, height is 8. All right, let's see, do we know the volume of the square pyramid? So that it's side length squared, so the side times the side, well, the sides match what's down here, which is 12, so S is 12, and this is the height, but we don't know the height. All right, so let's see, find the length of the diagonal of the base of the jewelry box. Okay, so what they're asking for, the diagonal of the base, that is this. This is a diagonal, okay? And because this is a 3D shape kind of drawn on a 2D surface, you can't really tell this, but this is, all of these are right triangles. So since this makes a right triangle, I can figure this out because I have the two legs, but I need the hypotenuse. So A asks for the length of the diagonal. So this is a leg, this is a leg, this is an unknown. So it's going to be 12 squared plus 12 squared equals the diagonal, whatever that is, squared. So you're going to use that to figure out how far this is. And then it says, find the height of the cover. Well, we know this is the height of the cover. This is our unknown. This is going to be the height of the cover. This is our diagonal, this is the height. We know that this is 10 inches. Now, because we found this, once you know what this one is going to be half as long. So whatever this is, divide it in 2, and then you'll know this side. And once you know this side, then you have two knowns and you can figure out what the height of the cover is. All right, the last thing says find the total volume. Once you have all those, you can put these into the formula and find the total volume. And it is an addition problem. Find the volume of the rectangular prism, and then find the volume of the square pyramid and add them together. That's what you would get for C. All right, number 5, last one. A metallic cylinder has a cone-shaped hole cut out of it. As shown, find the depth of the hole and then find the volume of the remaining metal. Okay, since we're dealing with volume, this is a cylinder and a cone is cut out. So the volume of the cylinder is pi r squared times the height. Well, do we know what the radius of the cylinder is? Yes, we do, because the diameter is 12, so the radius is going to be 6. Do we know the height? Well, yes, we do. The height is 18. Okay. Now the cone, the height of the cone is actually from the center down. Okay. This is the height of the cone, which is also the depth of the hole. So if we find the height, we're going to find the depth. Make that a little better. Okay. So this is the radius, and this circular face matches this one. So the radius would be 6. This is our unknown, but this is 10. So you can put this into the Pythagorean theorem to find the depth of the hole, okay? The volume of the remaining metal, once you have that, this height is the depth of the hole. And you can put the numbers into these volumes and then subtract them to find the volume of what's left. All right, that was a lot. But as you can see, you can use the Pythagorean theorem to help you find the measures of solid figures. So good luck with this. I hope you guys do well. And if you have questions, contact me during office hours. Have a great day.